So this lesson is going to be about how to make a reaction go faster. And formally, what we'd call it is the factors affecting the speed or the rate of a chemical reaction. So before we get into any details about how to speed up a chemical reaction, I'd like you to make your own list of ways you think that we can speed up a chemical reaction. And then as we go through the lesson, you'll be able to tick off whether or not your predictions were correct or not. Okay, so if you need any time to make that list, just pause the video and then continue after you've made your list. Okay, so the first experiment, if you're in class, that you will be doing in order to investigate how to make a reaction go faster is to try a reaction but change the size of the particles used in the reaction. Now, the chemical reaction that you will be doing for this experiment is to react chalk with acid. Now, whenever we're doing this, you have a test tube rack, you have 4 test tubes, and inside each test tube you would add some acid, hydrochloric acid, and then you would be adding different sources of chalk. Now, whenever we're talking about particle size, the smallest particle size that you can get is a powder. So that would be going in test tube 1. In test tube 2, we'd be looking at really small blocks of chalk. So ones that you'd be able to see almost like a bit bigger than sand. And the final one would be lumps of chalk. So a lump of chalk might look a little bit like a small pebble. And those would go in the test tubes. Now, before you add the chalk, what you would be doing is getting a stop clock or a stopwatch ready in order to record how long it takes for the reaction to finish. Now, in order for you to do that, you need to know what the sign of this chemical reaction is. Now, this chemical reaction is fizzing. We'll see bubbles appearing. And you will time your reaction, and when the bubbles stop being produced, that means the reaction is over. And so if that's the case, the quickest reaction will be the one that takes the shortest amount of time to stop producing bubbles. Now, as you can see in this experiment, we've done 3 experiments that have chalk inside them, and then we have another test tube with no chalk inside it. That's called a control experiment, and I'd like you to think of reasons why we might want to do an experiment without chalk in it, why we would do a control experiment. I would also like you to take the opportunity now to make a prediction. Which one of the test tubes, 1, 2, or 3, the ones with chalk in them, which one do you think would react quickest, and which one do you think would react slowest? So keep those predictions in your head, or if you want to, you can write them down on a sheet of paper. And what we will do on the next slide is we'll reveal what should happen in the experiment if you are in the unfortunate position that we don't get to do this experiment. So when we do this experiment, we look for which one stops bubbling, stops fizzing first. And we keep measuring all of them until they've finished fizzing. Now, what you should find is that the fastest reaction, the one that stopped fizzing first, used powder, and the reaction that kept bubbling for over 10 minutes, I think, was the big lumps. Now, what we can conclude, the conclusion from this, is relating the particle size to the speed of the reaction. Powder is a lot smaller than big lumps, and so the smaller the particle size, the faster the reaction. That conclusion is what you need to know. If you want to make a reaction go faster, you grind your chemical up so that the particles are as small as possible. So to speed up a reaction, you want very, very small particles. I also asked, what do you think the purpose of the control experiment was? Well, the control experiment, the purpose of it is to show that the chalk was needed for the reaction to happen, that the acid on its own didn't bubble. So it proved that the reaction only happened whenever there was chalk in it. And that's what control experiments are always used for. Now, control experiments are more common in biology, but we can sometimes have them in chemistry. Now, here is a numeracy question. What we've got were 4 different groups, and each group did an experiment with powder and each group did an experiment with lumps of chalk, and they recorded how long it took. What I would like you to do is to calculate the average for each of those. So you might want to pause the video while you work that out. So you might want to pause the video. Remember that the equation for calculating an average is you add together all the groups, all the numbers. So in this case, the value for group 1, group 2, group 3, group 4, and then you divide it by the number of groups. So that in this case is 4 groups. Okay, so hopefully you've worked those out. The averages for the powder, the average time was 8. So if you add up those 4 numbers, 6, 8, 9, and 9, you get 32. Divide it by 4, that ends up a value of 8. The other numbers, which you probably would need a calculator to add them all together, if you add them up, you get 96, and 96 divided by 4 is 24, which is the average number. Now the second question is, which one was reacting faster, powder or lumps? So the one that reacts fastest is the one that finishes first, and the one that finished first was the powder. What we're going to do now is look at a second factor that could affect the chemical reaction, and that is temperature. Now, when it comes to temperature, the experiment we do is a slightly different one. In this case, we've got 3 test tubes, and in the test tube, we're adding this solution called Benedict solution. And Benedict solution is a blue solution, which, when it reacts with glucose, turns green, then yellow, then orange. And what we're going to do is we're going to mix the Benedict solution with glucose, but then we're going to leave the test tubes at different temperatures. One's going to be at 20 degrees, one at 50 degrees, and one at 80 degrees. And we're going to wait for 5 minutes, and we will see which one changes color first. So what I'd like you to do at this stage, every single reaction has the same amount of Benedict solution and the same amount of glucose, so it is a fair test. The only thing that's changing, the only variable that's changing is temperature. I would like you to predict which one of those, the one at 20 degrees, the one at 50 degrees, or the one at 80 degrees, which one do you think would change color fastest, and which one do you think would change color slowest? If you want to write down your answers, you can pause the video to give yourself time to do that. So here, we're going to see the conclusions for that experiment. The reaction which changed color first, which took the fastest, was at 80 degrees, and the slowest reaction was the one at 20 degrees. Actually, at 20 degrees, that reaction might only start to turn green after about 50 minutes. So if you were doing that reaction in class, you might not see anything happening to the one at 20 degrees. The conclusion we can make relates the temperature to how fast the reaction goes. And in this case, we see that the greater the temperature, the faster the reaction, or the higher the temperature, the faster the reaction. So if we want a reaction to go quicker, we would do it at a higher temperature. It's just like drying your hair. If you want your hair to dry faster, you put the hair dryer on at a higher temperature. We have got one more thing to look at. So we looked at particle size we looked at temperature. Now we're going to look at something else. We're going to look at things called catalysts. Now, some of you might have heard catalysts. They might have been power-ups or things in games. But a catalyst is a chemical that you can add to a reaction which makes it speed up. But what is special about a catalyst is that you get it back. It is unchanged at the end of the reaction. And that means it can be reused over and over and over again. And because it can be reused over and over and over again, you only need a very small amount of it in order to make a reaction go faster. So catalysts are another way of speeding up a reaction. Now, the experiment that shows catalysts is called elephant's toothpaste. If you type elephant's toothpaste into Google or on YouTube, you will see a whole host of really big experiments. They are much more impressive than what we can do in school. So I suggest that you have a look at one of those. And in those, what happens is that a small amount of catalysts get added to a chemical called hydrogen peroxide, and it produces loads and loads of bubbles all at once. So have a look at elephant's toothpaste on the internet, and you'll see a really cool experiment. Catalysts don't have to be chemicals, they can be biological things. So our bodies and all living things contain enzymes, and enzymes are just biological versions of catalysts. So catalysts don't have to just be chemicals made by man, or by people, sorry. Catalysts that exist in nature are called enzymes. And catalysts are used to try and make things more environmentally friendly. So catalysts are put on exhaust pipes in order to make the gases that come out of cars and buses, etc., less toxic. So a catalytic converter is called a catalytic converter because it contains a catalyst. So, summarizing all of those things together, what we learned was that there were 3 ways to speed up a chemical reaction. The first one, if we want a reaction to go faster, we want as small as particle size as possible. So we want to use a powder if we can, small particle size. The second thing that we could do was we could increase the temperature. So the hotter a reaction happens at, the faster it goes. And thirdly, we could use a catalyst. And remember, a catalyst is special because it can be used over and over and over again. Now for the last couple of minutes, what I've got is a set of questions. As always, you can pause the video to give yourself time to write the answer down, or if you've got the answer in your head and you don't want to write it down, you can just play the video. So first thing, this is a revision question related to the topic from last time. Give one sign of a chemical reaction. One sign of a chemical reaction. There are lots of different ones. So one sign, you could have said smell being given off, color change, gas given off, solid appearing. I haven't put on this, but you could have said it gets hot. You could say it gives off light. Anything like that. Fizzing, bubbles, all of those are signs of chemical reaction. Give examples of 2 everyday chemical reactions. So 2 types of chemical reactions that happen all the time. So again, remember, you can pause the video to give yourself time to think or to write down. I'm going to give some answers now. So eating food to get energy, burning petrol, those are 2 useful ones. 2 not so useful ones are food going bad or rotting and nails rusting. But you could have had making toast, cooking eggs. Those are all examples of everyday chemical reactions as well. Now, the starting substances used in a chemical reaction are called what? And the final substance or substances are called what? So what do we call the things we start with in a chemical reaction? What are the things we finish with in a chemical reaction? This again is revision from last time. So the things we start with are the reactants, and the things we finish with are the products. So this is even further back revision. When 2 elements react together, what do we produce? When 2 elements react together, what is produced? Well, the thing we produce is a compound. When a compound is formed, the elements are what together? So this is 2 words, and we have to be very specific. When a compound is formed, the elements or the atoms of the elements are something together. Words we're looking for are chemically joined together. Remember, the definition of a compound is a chemical that contains more than 1 type of atom chemically joined together. And finally, we've got a maths question. So all of this has been revision. What we've got here is we've got temperature and we have got time. And what we're looking for is a general statement describing the effect of temperature on the rate of the reaction. So when we're just talking about a general statement, what we're looking for is, as this happens to the temperature, something happens to the time. So as something happens to the temperature, what happens to the time? So that one, as the temperature increases or it gets hotter, the time decreases. So that was a set of revision questions. Hopefully you remembered all of those. And if not, you can keep going and watching these videos over and over and over again until you've got it perfect. But thank you for your attention this time, and I will see you next time.